So we're going to take a look at how to prove the Pythagorean theorem. So the proof of the Pythagorean theorem goes like this. First you need to construct two identical squares. These two squares have side length a plus b. Both of them have side length a plus b. In the first square, you can draw the lines that cut the squares vertical and horizontal, so that you have a little square that has a by a and a bigger square that's b by b, and then two rectangles that are b by a. And in the square to the right, what you do is you cut the square again with lines that go diagonal and form four triangles that have a base of a and a height of b. Now let's label in the right square, the small square inside has edges c by c. Now these are all identical triangles, so the hypotenuse all have side c, so it is in fact a square with side c, which means that the area of the big square, the area of the little square inside is c squared, and the area on the left of the little square AA and BB is a squared and b squared as such. Now remember, these two bigger squares on the left and on the right of the equal sign have the same area because they have the same length of sides, a plus b. So if I take away anything from the left side, I have to take away the same amount from the right side for the equality to stay true. Let's take a look at what happens if we cut the rectangle. On the left side there's two rectangles, b by a. Let's see what happens when we cut that in two with a diagonal line. It creates four triangles that have base a and height b. Exactly the same triangles as on the right hand side, but they've just been placed in a different configuration. So I'm going to remove those four triangles from the left side and from the right side because it's the same amount from left and right that I'm taking away, and I'm going to remove them by painting them one at a time yellow. After you take away these four triangles from both sides, you see that on the left hand side you're left with two squares with area a squared and the other one is b squared. And on the right hand side you're left with one square whose area is c squared, which means, since the equality still holds, the area on the left is a squared plus b squared and the area on the right hand side is c squared. A squared plus b squared equals c squared, and we've just proven the Pythagorean theorem.